Video 7, Simple Algorithms. Finally, we'll write a few simple algorithms. Algorithms can be really complicated, but simple ones are just like the functions we've written before. An algorithm is defined as a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. These are the same ones that make TikTok so addicting and Netflix so accurate. One really simple algorithm is the binary search. I don't know about you, but we used to play a game called Guess the Number back in elementary school. Someone chooses a number and you have to guess it. They tell you higher, lower, or correct, and the least number of guesses wins. Guessing the middle number is always the best choice because with each guess you can chop off half of the choices. So let's simulate this old game. Let's say choose a number 1 through 50. We are going to use random from before to generate a random number, and we will also use a loop. First, we will need to import random, as we have done here. Create a function that will house our algorithm, and this is going to be called binary search. We need two variables to begin with, the lower bound and the upper bound, and they store integers. We also need a variable to contain our count and the number of guesses. Count is what the actual count is going to be after you have each time. Finally, we need a variable to label the target value, one we don't know yet, but the computer will randomly generate for us, and we can call this the target. And we want to print this out to analyze what the computer randomly generated for us later. Now we can build a loop. While our guess is not equal to target, we need to keep guessing. Remember, this algorithm will automatically guess for us each time, always taking the midpoint value after halving. To calculate guess each time in the loop, we just take the lower and upper bounds and find the average, so dividing by 2, not taking any remainders, of course. Remember to use 2 forward slashes, since 1 will give you a decimal value, which you don't want. 2 forward slashes means integer division, which will give you a whole number guess. It rounds down if you get a decimal. And we want to print this for us as well, as this will tell us what each guess is. Now, using logic, we can think of 3 scenarios. Either the guess is going to be less than the target, greater than the target, or equal to it. If it is less than the target, which is the first case here, we know all values below guess are not correct. So we want to assign our lower bound to our target guess, so the next guess will be recalculated based on this. We also need to increment the guess counter because we guess once, incorrectly of course. Else if the guess is greater than target, we basically want to do the opposite case here. We assign the guess to be the new higher bound, and we need to once again increment the guess count. Else, finally, the last case is if we guess on the dot, which we eventually will since we are squeezing our range through reassignment each time by half. When this is the case, we increment one final time for the correct guess and then return the number of guesses that we have used up. We can also write a safety case seen here, and this is outside of the while loop. This is great in case a guess is out of bounds. It won't happen in our controlled case, but if you're making, say, a product for users who might try to game the system, this would be a good catch. And now we can print out the number of guesses it took, which will call this program to run. Hitting run, we see the target and how we start at the middle case of 25 because 25 is between 1 and 50 and continue to squeeze the range until we hit the target. It guesses by half each time. The target is 33, so 25 of course is low, so then it's going to squeeze the range between 25 and 50. Then it's going to guess 37 and it's going to continue squeezing the range. See, sometimes it might guess too high, sometimes it might guess too low, but eventually it'll get to the correct target guess, which is 33, and it'll count up the number of guesses we took, which if you count here, you see that there were 6 guesses, which it prints out for us. As a concluding point, I want to emphasize the importance of reading documentation. Documentation at Python.org is like reading a user manual or having the full library at your fingertips. If you ever want to know the full range of functions available, or need help, or get stuck, it's really easy to look it up inside the documentation. With that, I hope you continue to grow in your CS knowledge. Please leave any comments below, make sure to like, subscribe, and share with your friends. Thanks so much for watching, and hope to see you in another one.